can accommodate 1.3 million Earths. From the powerful eruptions to the steady stream of charged particles, the Sun influences the nature of space throughout the solar system. Sun doesn't spin like, let's say, the Earth. Sun is made up of super hot, electrically charged gas called plasma. This plasma rotates at different speeds on different parts of the Sun. At its equator, the Sun completes one rotation in 25 Earth days. At its poles, the Sun rotates once on its axis every 36 Earth days. The temperature in the Sun's core is about 27 million degrees Fahrenheit, or 15 million degrees Celsius. It is so hot that it can sustain a nuclear fusion. This creates outward pressure that supports the star's gigantic mass, keeping it from collapsing. Above the Sun's surface are its thin chromosphere and the huge corona or the crown. This is where features such as solar prominences, flares and coronal mass ejections happen. Sun flares and coronal mass ejections are giant explosions of energy and particles that can reach Earth. A solar probe typically looks at studying all of these from a safe distance so that nothing gets burned down. Solar probes are also carried out to predict successfully the flares and giant explosions that propel particles from it and can cause serious damage to any spacecraft. Center and has the capability to alter atmospheres of different planets, including Earth. Sun is a relatively younger star in our galaxy. Study of the Sun helps understanding other stars in the Milky Way and galaxies beyond. The various thermal and magnetic phenomena on the Sun are of extreme nature, so the Sun provides a good natural lab to understand those phenomena. These otherwise cannot be directly studied in the lab. All these studies lead to a better understanding of Earth, its atmosphere, genesis of this solar system, and the universe.
Riding high on Chandrayaan-3's successful landing, ISRO is now gearing up for the next cosmic quest. Aditya-L1 mission is what we are talking about. This is ISRO's first solar mission. We're talking about India's feet on the moon, eyes now on the sun. Let's talk about this particular mission, Aditya-L1, which, like I said, is ISRO's India's first solar mission. The vehicle first. Aditya-L1 is going to be hitching a ride on India's heavy-duty launch vehicle, which is the PSLV-XL. The PSLV-XL weighs 320 tons and the height is 44.4 meters. The PSLV-XL is a four-stage vehicle with multiple satellite launch capabilities and multiple orbit capabilities. Just take a look at how this essentially is going to take off and place itself on the Sun's halo orbit.
And lift off.
What then is the Lagrange point? Now named after Joseph Louis Lagrange, a French mathematician who first studied them in the 18th century. The Lagrange points are points in space where the gravitational forces of two large bodies such as the Sun and the Earth balance out, creating a region of equilibrium. Now these points in space can be used by spacecraft to reduce fuel consumption needed to remain in position. There are 5 of them: L1, L2, L3, L4 and L5. L1 is about 1.5 million kilometers from the Earth, or approximately 1% of the Earth-Sun distance. It is essentially the vantage point. Let's talk about the journey to L1. Well, after being placed in a low Earth orbit by ISRO's PSLV-XL rocket, the orbit is going to be made more elliptical, and spacecraft will be launched towards L1 point by using on-board propulsion. As the spacecraft travels towards L1, it will exit Earth's gravitational sphere of influence, or SOI. After the exit, cruise phase will start and craft will be injected into a large halo orbit around L1. It is going to take 4 months for the spacecraft to reach its destination. So why are we studying the sun? The sun, remember, is the nearest star and therefore can be studied in much more detail as compared to other stars, for example. Now, by studying the sun, we can learn much more about stars in our Milky Way as well as about stars in various other galaxies. Sun's explosive solar phenomena, if directed towards the Earth, could cause various types of disturbances in the near-Earth space environment. To learn about and track Earth-directed storms and to predict their impact, continuous solar observations are required. Every storm that emerges from the sun and heads towards Earth passes through L1. The various thermal and magnetic phenomena on the sun are of extreme nature. Thus, the sun also provides a good natural lab to understand those phenomena which can't be directly studied in any other lab. What then are the main objectives of this solar mission? The spacecraft carries 7 payloads designed to study the sun's atmosphere and its interaction with the solar wind. The mission is aimed at studying the super high temperatures of solar corona, the dynamics of solar system and the solar temperature non-uniformity. It will also study and evaluate the main drivers of space weather. Let's now talk about Aditya-L1 science payloads here. Now, of the 7 payloads, 4 will directly study the sun and the remaining 3 will in situ carry out in situ studies of particles and fields at the Lagrange point, that's the L1. The science payloads of Aditya-L1 are indigenously developed by different labs in the country. With 1 billion people praying for ISRO's success in unison, the countdown to Mission Sun has officially begun.
Aditya means the sun, and L1 is the point between Earth and Sun that offers an uninterrupted view of the closest star of our galaxy, hence the nomenclature of the latest ISRO project. Sun is the main source of energy of this solar system and holds the biggest secret of this universe. Aditya-L1 of ISRO is the first Indian attempt to study and understand the sun. Aditya will first be placed on Earth-centered orbit before embarking on a 150 million kilometer journey from Earth's sphere of influence to different viewing points around the sun. It will be placed in a cruising position at L1 between the Earth-Sun system in the halo orbit. The temperature at the surface of the sun is about 10,000 Fahrenheit or 5,600 degrees Celsius. So there's no way anything comes remotely close to its surface without burning down to unimaginable ash particles. So all sun missions are posted at different viewing points between the sun and the earth. These are called Lagrange points. These points are used by the spacecraft to station with minimal use of fuel while they continue to study the sun from a safe distance. There are a total of 5 Lagrange or L points. Aditya would be placed at L1 that lies between Earth and the sun. Aditya-L1 will carry 7 payloads. 4 of them will carry out remote sensing of the sun and 3 others will do in situ observations. To understand changes in Earth's ecosystems, study ice mass, vegetation, biomass, sea level rise. These observations and studies will help understand the groundwater of Earth and different natural hazards like earthquakes, tsunamis, volcanic eruptions and landslides. In total, 9 solar missions have happened so far by countries like the US and the European Union to different Lagrange points of the sun. Aditya-L1 comes with the promise to open up a new galaxy of knowledge for India.
7 decades of space exploration, solar missions are relatively a new phenomenon. It all started in this millennium as India prepares for this maiden solar mission launch. A quick interview or an overview rather of why probe the sun in the first place. Have a listen.
Sun keeps the solar system together, from the biggest planet Jupiter to the smallest particles in its orbit. 4.5 billion years old Sun is a hot glowing ball of hydrogen and helium. Sun can accommodate 1.3 million Earths. From the powerful eruptions to the steady stream of charged particles, the Sun influences the nature of space throughout the solar system. Sun doesn't spin like, let's say, the Earth. Sun is made up of super hot, electrically charged gas called plasma. This plasma rotates at different speeds on different parts of the Sun. At its equator, the Sun completes one rotation in 25 Earth days. At its poles, the Sun rotates once on its axis every 36 Earth days. The temperature in the Sun's core is about 27 million degrees Fahrenheit, or 15 million degrees Celsius. It is so hot that it can sustain a nuclear fusion. This creates outward pressure that supports the star's gigantic mass, keeping it from collapsing. Above the Sun's surface are its thin chromosphere and the huge corona or the crown. This is where features such as solar prominences, flares, and coronal mass ejections happen. Sun flares and coronal mass ejections are giant explosions of energy and particles that can reach Earth. A solar probe typically looks at studying all of these from a safe distance so that nothing gets burned down. Solar probes are also carried out to predict successfully the flares and giant explosions that propel particles from it and can cause serious damage to any spacecraft. Center and has the capability to alter atmospheres of different planets, including Earth. Sun is a relatively younger star in our galaxy. Study of the Sun helps understanding other stars in the Milky Way and galaxies beyond. The various thermal and magnetic phenomena on the Sun are of extreme nature, so the Sun provides a good natural lab to understand those phenomena. These otherwise cannot be directly studied in the lab. All these studies lead to a better understanding of Earth, its atmosphere, genesis of this solar system, and the universe.
Riding high on Chandrayaan-3's successful landing, ISRO is now gearing up for the next cosmic quest. Aditya-L1 mission is what we are talking about. This is ISRO's first solar mission. We're talking about India's feet on the moon, eyes now on the sun. Let's talk about this particular mission, Aditya-L1, which, like I said, is ISRO's India's first solar mission. The vehicle first. Aditya-L1 is going to be hitching a ride on India's heavy-duty launch vehicle, which is the PSLV-XL. The PSLV-XL weighs 320 tons and the height is 44.4 meters. The PSLV-XL is a four-stage vehicle with multiple satellite launch capabilities and multiple orbit capabilities. Just take a look at how this essentially is going to take off and place itself on the sun's halo orbit.
And liftoff.
What then is the Lagrange point? Now named after Joseph Louis Lagrange, a French mathematician who first studied them in the 18th century. The Lagrange points are points in space where the gravitational forces of two large bodies such as the Sun and the Earth balance out, creating a region of equilibrium. Now these points in space can be used by spacecraft to reduce fuel consumption needed to remain in position. There are 5 of them: L1, L2, L3, L4 and L5. L1 is about 1.5 million kilometers from the Earth, or approximately 1% of the Earth's sun distance. It is essentially the vantage point.
Calling T1, switch on the pulsar.
To L1 will, after being placed
नमस्कार,
in a low Earth
एक बार
orbit
फिर
by
स्वागत
ISRO,
है आप
the
सभी
SLV
दर्शकों
XL
का।
rocket
मैं
will
विकास
be
स्वर्णकार
more-
यहाँ
made
श्रीहरिकोटा
more
के
electric.
मिशन नियंत्रण
And
कक्ष से
spacecraft will be launched
इस मिशन
towards
की
L1
समीक्षा
point
प्रस्तुत
by
करूंगा
using
और मेरे साथ
onboard
हैं
propulsion.
इंग्लिश
As the
कमेंटेटर मिस
spacecraft
माधुरी
travel
पी।
towards L1, it
सबसे
will
पहले
exit
आप
Earth's
सभी दर्शकों को
gravitational sphere
हार्दिक
of
शुभकामनाएं
influence,
और
or
बधाइयां
SOR.
चंद्रयान 3
After
मिशन
the
की
exit,
जिसने
crew
पूर्ण
space will
सफलता के
start
साथ
and
23
craft
अगस्त
will be
2023 को
injected into a
चंद्रमा की
large
सतह पर लैंडर
halo
की
orbit
सकुशल
around
लैंडिंग की
L1. It is
और
going to take
इसके
4
बाद
months for the
रोवर ने
spacecraft
पृथ्वी
to
से
reach
3,80,000
its
किलोमीटर
destination.
दूर चंद्रमा पर विचरण
So
कर
why
भारत
are
की
we
अमिट
studying
छाप
the
छोड़
sun?
दी
The
है।
sun, remember, is
इसके
the
साथ ही
nearest star
भारत
and
चंद्रमा
therefore
के
can be
दक्षिणी
studied
ध्रुव
in
पर
much more
सकुशल
detail as
उतरने वाला
compared to other
विश्व का
stars,
पहला
for
देश
example.
बन चुका है।
By studying the sun, we can
यह
learn
सब
much
संभव
more
हो
about
पाया है
stars
इसरो
in our
के
Milky Way
कुशल
as well as
मार्गदर्शन
about
और
stars in
वैज्ञानिकों के
various
अथक
other
प्रयास
galaxies.
से।
Sun's
लेकिन ये
explosive
तो सिर्फ
solar
शुरुआत
phenomena,
है।
if directed towards the
चंद्र-
Earth, could cause various types of disturbances
इसरो-
in the near-Earth space environment.
इसरो
To
तेजो
learn
में
about
सूर्य के
and track
अध्ययन के
Earth
प्रयोजन से
directed storms
आदित्य-L1
and
नामक
to predict
अंतरिक्ष
their
यान को
impact.
आज 2
Continuous
सितंबर
solar observations are
2023 को
required.
श्रीहरिकोटा के
Every
द्वितीय
storm
प्रमोचन
emerges
मंच
from the
से
sun and
भारतीय
heads
मानक
towards
समय के
Earth,
अनुसार
passes through L1.
सुबह 11:50
Various thermal and
पर
magnetic
PSLV
phenomena on
C-57
the sun
रॉकेट
are
द्वारा
of extreme
प्रमोचित
nature.
करेगा।
Thus, the sun
आइए
also provides a
चलें
good
सूर्य की
natural
ओर
lab
और विज्ञान के
to
कुछ और
understand
रहस्यों से
those
पर्दा उठाने
phenomena
और
which
वैज्ञानिक
can't be
तकनीक का
directly
प्रदर्शन
studied
करने।
in
तो
any
बने
other
रहिए
lab.
हमारे साथ
What then
आज
are the
के इस
main
मिशन में
objectives
जिसका
of
नाम
this
है
solar mission?
PSLV
The spacecraft
C-57
carries 7
आदित्य-L1
payloads
मिशन।
designed to study the sun's atmosphere and its interaction with the solar wind.
Namaste,
The mission is
viewers.
aimed at studying the super
Indian
high
Space
temperatures,
Research
solar
Organization
flame, the
is
dynamics
gearing
of
for
solar
its rendezvous
system
with the sun.
and the solar temperature
To take you along
non-uniformity.
on the live
It will also
telecast
study
of this
and
momentous
evaluate
event
the
today,
main drivers
I am Madhuri,
of space
giving the
weather.
commentary in English.
T4 remote here, you can switch
With
on
me
the
is
radio.
my
Let's now talk
co-commentator,
about
Vikas
Aditya-L1
Swarnkar,
science
who will be
payloads.
giving
Here.
the
Now, of the
commentary
7
in Hindi.
payloads, 4 will
We are about
directly
to
study the
script
sun, and the
yet
remaining
another chapter
3
in the
will in
glorious
situ
space
carry
research
out
history of
in
India.
situ studies of
Today,
particles
the
and
workhorse
fields
rocket
at the Lagrange point
PSLV
at L1.
C-57
The science
will
payloads
carry
of Aditya-L1 are
Aditya-L1, the
indigenously
solar
developed by
observatory of
different
India,
labs in the
to
country.
be placed at a vantage point
With a
from
billion
where it
people
will be
praying
able
for
to
ISRO's
continuously
success in
observe the
unison,
sun,
the countdown
and while
to
being in the
mission
visibility
sun
of
has
Earth-based ground
officially
stations.
begun.
10 days ago, India
Aditya
became the
means
first
the sun.
country in the world to safely
L1
land a
is the point
spacecraft
between
in the
Earth
South
and
Polar
sun.
regions on the moon.
That offers an uninterrupted
I'm sure many of you were the
view
eager
of the
and proud
closest star
spectators
our
of the
galaxy.
Chandrayaan-3
Hence
landing
the
that was being
nomenclature of
telecast
the
from
latest ISRO
ISRO,
project.
situated
Sun is the
in
main
Bangalore.
source of energy of this solar system and holds the biggest secret of this
We
universe.
bring to you an integration film for
Aditya-L1
the
of ISRO is the first
C-57
Indian
that took
attempt
place
to
in
study
Satish
and
Dhawan Space
understand
Center,
the sun.
Sriharikota.
Aditya will first be placed on Earth's centered orbit before embarking on a 150 million kilometer journey from Earth's sphere of influence to different viewing
अभी
points
आप
around
अपनी
the sun.
स्क्रीन पर देख रहे हैं
It will be
यह है
placed in a
प्रथम
cruising position
चरण
at
S139
L1
booster
between the
का nozzle and
Earth-Sun
segment।
system in the halo orbit.
प्रथम चरण के साथ ये
The
शुरुआत
temperature
होती
at the
है और
surface
यह
of the
मिडिल
sun
सेगमेंट
is
को
about
इसके ऊपर
10,000 Fahrenheit
संयोजित किया जा
or
रहा है।
5,600
ऐसे
degrees
मिडिल सेगमेंट
Celsius.
इसके ऊपर
So there's
संयोजित
no
किए
way
जाएंगे और
anything
अंत
comes
में
remotely
hidden
close
segment
to its surface without
सबसे
burning
ऊपर
down
की ओर
to
संयोजित किया जाएगा और
unimaginable
इस तरह
ash
तैयार होता है
particles.
PSLV का प्रथम चरण
So
कोर
all
बूस्टर
sun missions
S139
are posted at different
इसमें
viewing
139
points
टन का
between the
प्रणोदक
sun
होता
and
है
the
और यह
earth.
इग्नाइटर है
These
जो
are
इसे प्रज्वलित
called
करता है।
Lagrange points. These
इस-
points are used
इस
by the
मिशन पे यह है
spacecraft to
PSLV
station with minimal use
C-57
of fuel
एक्सेल मिशन।
while they continue to
तो
study
इसमें
the
हैं
sun from a
6
safe
स्टेप-ऑन
distance.
बूस्टर्स
There
हर
are
एक
a
में
total
12
of
टन
5
के
Lagrange
नोदक भरे
or
जाते
L
हैं।
points.
यह सब
Aditya
ठोस
would be
नोदक पर
placed
आधारित हैं।
at L1 that lies between Earth and the sun. Aditya-L1
यह
will carry
SITC
7
tank
payloads.
को
4
उठाकर
of them
इसके
will
साथ
carry out
संयोजित किया
remote
जा रहा है।
sensing of the sun and 3
इधर
others
स्टेज आप
will
देख
do
रहे हैं
in
इसमें
situ
रिट्रो मोटर्स लगे हुए
observation.
हैं पृथ्वीकरण के लिए।
To understand changes in Earth's ecosystems, study ice mass, vegetation,
और यह
biomass,
है
sea
द्वितीय
level
चरण
rise.
जो कि
These
तरल नोदक पर
observations
आधारित
and
चरण है।
studies
इसमें
will
विकास
help
इंजन लगा हुआ
understand
है।
the groundwater of Earth and different natural
And
hazards
here is the second
like
stage
earthquakes,
of the PSLV
tsunamis,
rocket,
volcanic
prepared in the
eruptions, and
subsystem preparation
landslides.
facility and brought to the vehicle
In
assembly
total,
building of the
9
second
solar
launch
missions
pad
have happened
to be
so
integrated
far by countries like
on
the
the
US
first
and the
stage of the
European
rocket.
Union to
Here you
different
can see
language
the
points of the
third
sun.
stage PS3
Aditya-L1
and PSOB
comes with the
module
promise to open up a new galaxy of knowledge
and
for
placed
India.
inside
7 decades of
shroud
space
and then handled
exploration,
together
solar missions are
to be
relatively a
moved
new
to the
phenomenon.
vehicle
It all
assembly
started
building.
in this millennium as India prepares for this maiden solar mission launch. A quick interview or an overview rather of why probe the sun in the first place. Have a listen.
ये नज़ारा आप देख रहे हैं व्हीकल असेंबली बिल्डिंग का जहां पर पूरे व्हीकल को असेंबल किया जाता है
These are the visuals from the clean room of the spacecraft
to the
preparation
smallest
facility.
particles in its orbit.
This is the Aditya-L1 spacecraft being prepared and
4.5 billion
ensconced
years
into a
old sun
protective
is a hot glowing
container
ball of hydrogen
where
and
the
helium.
environment is controlled and the temperature is controlled.
Sun
the
can
cleanliness
accommodate
is controlled.
1.3 million Earths.
At the vehicle assembly building, again there is a clean room provision to safely
From the powerful
integrate it to
eruptions
the,
to the steady stream
rocket,
of
and then the
charged
heat shield
particles,
halves are
the
closed.
sun influences
Now the vehicle
nature
is
of
fully
space
ready to be
throughout
moved
the
to
solar
the launch
system.
pad, which is about 900 meters away.
Sun doesn't spin like, let's say, the Earth.
This is PSLV C-57, standing majestically.
Sun is made up of
अभी आपने
super
देखा
hot, electrically charged
PSLV-C-57 का
gas called
इंटीग्रेशन
plasma.
वीडियो
This plasma
पूरी
rotates
तरह
at different
तैयार
speeds
और
on different
कुछ
parts
अंतिम
of the sun.
गतिविधियां जारी हैं, अंतिम जांच जारी
At
है
its
प्रमोशन
equator,
से पहले
the
की
sun completes one rotation in 25 Earth days. At its poles, the
We
sun
are bringing
rotates
this
once
telecast
on
to
its
you live
axis
from the Mission
every
Control
36
Center
Earth
at
days.
Satish Dhawan Space Center, Shar, Sriharikota.
The temperature in the
The
sun's
launch will
core is
take
about
place today,
27 million degrees
The
Fahrenheit,
2nd of September
or
2023
15 million
at
degrees Celsius.
11:50 hours in time from the second launch
It
pad.
is so hot that it can sustain a nuclear fusion.
PSLV C-57 in
This
its
creates
XL
outward
version
pressure
will carry
that supports the
Aditya-L1
star's
spacecraft having a mass
gigantic
of
mass,
1,480
keeping it from
kilograms. The mission intends to place the spacecraft
About
in
the sun's surface
235
are its
by
thin
19,500
chromosphere
kilometers
and the huge
orbit
corona
with an
on the crown.
inclination of
This is where
19.2
features
degrees.
such as solar
The total mission
prominences,
duration will
flares,
be
and coronal mass
3,799
ejections
seconds or 63 minutes 19
Sun
seconds.
flares and coronal
Apart
mass
from
ejections
Doordarshan,
are
you can watch the
giant
live telecast
explosions of
on
energy
ISRO website,
and particles
YouTube,
that can reach
Facebook
Earth.
and Twitter.
A solar probe typically looks at studying all of
अब
these
हम प्रमोशन
from a
से
safe
22 मिनट
distance
की दूरी पर
so
हैं।
that nothing gets burned down.
आदित्य-L1
Solar probe
सूर्य का
are also
अध्ययन करने
carrying
वाला
out to
पहला
predict
अंतरिक्ष आधारित
successfully
भारतीय
the
मिशन
flares
है।
and giant
इस मिशन
explosions
से
that propel
आदित्य-L1 नामक
particles from it
अंतरिक्ष यान को
and
सूर्य
can cause
पृथ्वी
serious
प्रणाली
damage
में
to
लैग्रेंज
these
1 पॉइंट
spacecraft.
के चारों
Center
ओर एक
and has the
प्रभामंडल कक्षा
capability
में
to alter
स्थापित किया जाएगा।
atmospheres of different
यह लैग्रेंज
planets.
पॉइंट पृथ्वी से लगभग
including
15 लाख किलोमीटर दूर है।
Sun is a
इस
relatively
तरह
younger
L1 पर
star
रखे
in our
गए
galaxy.
उपग्रह को
Study
सूर्य
of the
को
sun
बिना किसी
helps
आच्छादन या
understanding
ग्रहण
other
के
stars on the
लगातार
Milky Way
देखा जा
and
सकता है।
galaxies beyond. The various thermal and magnetic
यह
phenomena
अंतरिक्षयान
on the
विद्युत
sun
चुंबकीय
are of
और
extreme
कणचुंबकीय
nature.
क्षेत्र
So the sun
सूचकांकों का
provides a
उपयोग
good
करके
natural
फोटोस्फीयर,
lab to
क्रोमोस्फीयर और
understand
सूर्य
those
के सबसे
phenomena.
बाहरी परत जिसे हम कोरोना के नाम से जानते हैं, इनका निरीक्षण करने के लिए इसमें 7
These
नेत्रभार लगे हुए
otherwise
हैं।
cannot be directly studied in the lab.
इनमें से
All
4
these
नेत्रभार
studies
सीधे सूर्य
lead to
की
a better
गतिकी का अध्ययन
understanding of
करेंगे
Earth,
तथा अन्य
its
3 नेत्रभार
atmosphere,
L1 बिंदु पर
genesis
कणों और
of the
क्षेत्रों
solar
का
system
यथास्थिति अध्ययन
and the
करेंगे।
universe.
इस तरह आदित्य-L1 उपग्रह के नेत्रभार कोरोनल तापन, कोरोनल मास इजेक्शन, प्री फ्लेयर और फ्लेयर गतिविधियों और
Riding
उनकी
high on
विशेषताओं
Chandrayaan
और
3's
अंतरिक्ष मौसम
successful
की
landing,
गतिशीलता को समझने के
ISRO
लिए
is now
अत्यधिक
gearing up
महत्वपूर्ण जानकारी
for
प्रदान
the
करेंगे।
next cosmic quest. Aditya-L1 mission is what we are
अब
talking
आपके
about.
सामने
This is
प्रस्तुत
ISRO's
है
first
Aditya-L1
solar
curtain
mission.
raiser।
We're talking about India's feet on the moon, eyes now on the sun. Let's talk about this particular mission, Aditya-L1, which, like I said, is ISRO's India's first solar mission. The vehicle first. Aditya-L1 is going to be hitching a ride on India's heavy-duty launch vehicle, which is the PSLV-XL. The PSLV-XL weighs 320 tons and the height is 44.4 meters. The PSLV-XL is a four-stage vehicle with multiple satellite launch capabilities and multiple orbit capabilities. Just take a look at how this essentially is going to take off and place itself on the sun's
The sun,
halo orbit.
which is the center of our solar system and has always fascinated humans, is a ball of
What
hot
then is
gases
the Lagrange
formed by
point,
the
now
neutral
named
fusion
after
process.
Joseph Louis Lagrange, a French
The
mathematician
visible outer
who first
surface of the
studied
sun
them
is
in the
known
18th
as the
century. The Lagrange
photosphere,
points are points
followed by
in
the
space where the
chromosphere
gravitational
and then
forces
the
of
corona.
two large bodies such as
After
the sun
initially dropping
and the
through the
Earth balance
chromosphere,
out, creating
the
a
sun's
region
temperature
of equilibrium.
abruptly
Now, these
rises
points of
in the
space can be
corona,
used by
reaching
spacecraft to
extremely
reduce
high
fuel
values
consumption needed
of 1
to
to 3
remain
million
in position.
Kelvin.
There are 5 of them. L1,
The Aditya-L1
L2,
mission
L3,
has
L4,
7
and L5.
scientific payloads
L1
to
is about
conduct a
1.5
comprehensive
million
study of the
kilometers
sun.
from the Earth, or
The
approximately
Visible
1%
Emission
of
Line
the Earth's sun
Coronagraph,
distance. It is essentially
VELC,
the
investigates the
vantage
solar
point. Let's
corona
talk about
and the
journey
dynamics
to
of
L1
coronal
belongs
mass
to being placed
ejections.
in a low Earth orbit by ISRO's
The Solar
PSLV-XL
Ultraviolet
rocket.
Imaging
The
Telescope,
orbit is going to be
suit payload
made more
scans the
elliptical,
solar disk
and
in near
spacecraft will be
ultraviolet
launched
light
towards L1
and detects
point
fluctuations
by using
in solar
onboard
irradiance.
propulsion. As the
The
spacecraft
Aditya
travels
Solar
towards
Wind
L1,
Particle
it will
Experiment
exit Earth's
aspects
gravitational
and
sphere
Plasma
of
Analyzer
influence,
package
or
for
SOI.
Aditya,
After the
Papa
exit, cruise
payloads
phase will
investigate
start
the
and
solar
craft
wind and
will be
energetic
injected
ions,
into a
as well
large
as their
halo
energy
orbit around
distributions.
L1. It is going to take
The
4
Solar
months for
Low
the
Energy
spacecraft
X-ray
to reach
Spectrometer,
its destination.
Solexus, and the High
So
Energy
why are we studying
L1
the sun?
Orbiting
The sun,
X-ray
remember, is the nearest star
Spectrometer,
and therefore
Helios,
can be studied in
analyze
much more
X-ray
detail
flares
as
from
compared
the sun
to other
over a
stars, for
wide
example.
energy range.
Now, by studying the sun, we can learn
The
much more about
magnetometer
stars
payload
in our
is
Milky
designed to
Way as
measure
well as
the
about stars in
interplanetary
various other
magnetic field
galaxies.
at the L1
Sun's
point.
explosive solar phenomena, if directed towards the Earth,
Aditya
could cause
L1
various
is
types of
equipped to
disturbances
take
in
in
the
situ
near-Earth
measurements
space
of
environment.
charged
To learn
particles
about
and fields
and
at
track
L1
Earth-directed storms
and is dedicated
and
to
predict their
studying
impact.
the sun
Continuous
across
solar
several
observations
energy
are
bands.
required. Every
The
storm that
Lagrange
emerges from
point
the sun
L1
and heads
is
towards
located
Earth
around
passes through L1.
1.5
Various
billion
thermal and
kilometers
magnetic
from the
phenomena
Earth
on the
between the
sun
sun
are
and
of
the
extreme
Earth.
nature. Thus, the sun
These
also
observations
provides a
are
good
best
natural
made
lab
from a
to
vantage
understand
point
those
that provides a
phenomena
continuous
which can't
view
be
of the
directly
sun.
studied in any
All
other lab.
payloads are
What
designed in
then are the
close
main
coordination
objectives of this
with
solar
ISRO
mission?
centers
Spacecraft
and national
carries 7
laboratories
payloads
like
designed to
as
study the sun's
IIA,
atmosphere and its interaction with the
IUCAA
solar
and
wind.
PRL.
The mission is
With
aimed at
this
studying
mission,
super high temperatures,
ISRO
solar
will once
corona,
again
dynamics
demonstrate
of
its
solar
position
system,
in
and the solar
space
temperature
exploration.
non-uniformity. It will also study and evaluate the main drivers of space weather.
We are
Let's now
17
talk
minutes,
about
23
Aditya-L1
seconds from the
science
launch time.
payloads here. Now, of the 7
The countdown for
payloads, 4 will
PSLV
directly study the
C-57
sun, and the remaining
Aditya-L1
3
mission
will in
has been
situ
24
carry out
hours long.
in situ
It had
studies of
started
particles
yesterday.
and fields at the Lagrange point.
During
at
the
L1.
countdown,
The science
critical
payloads
activities
of
have been
Aditya-L1
carried
are
out on the
indigenously
launch vehicle
developed
and the
by different
spacecraft.
labs in the
The
country.
propellant have been serviced into
With
the
a
launch
billion
vehicle
people
stages.
praying for
Bottle
ISRO's
storing
success
the
in
gases with
unison,
command
the countdown
and
to
control
Mission
operations
Sun
have been charged
has
to
officially
pre-launch
begun.
pressure levels. The onboard
Aditya
batteries
means
have
the
been
sun.
charged.
And L1 is the point between Earth and Sun.
Now in a little while we'll go to
that
the
offers
automatic
an
launch sequence
uninterrupted
initiation,
view of the
for which the
closest star of our
preparations
galaxy.
are underway
Hence the nomenclature of the latest
in the
ISRO
launch and mission
project.
control centers.
Sun is the main source of energy of this solar system and holds the biggest secret of this universe. Aditya-L1 of ISRO is the first Indian attempt to study and understand the sun. Aditya will first be placed on Earth-centered orbit before embarking on a 150 million kilometer journey from Earth's sphere of influence to different viewing points around the sun. It will be placed in a cruising position at L1 between the Earth-Sun system in the halo orbit. The temperature at the surface of the sun is about 10,000 Fahrenheit or 5,600 degrees Celsius. So there's no way anything comes remotely close to its surface without burning down to unimaginable ash particles. So all sun missions are posted at different viewing points between the sun and the earth. These are called Lagrange points. These points are used by the spacecraft to station with minimal use of fuel while they continue to study the sun from a safe distance. There are a total of 5 Lagrange or L points. Aditya would be placed at L1 that lies between Earth and the sun. Aditya-L1 will carry 7 payloads. 4 of them will carry out remote sensing of the sun and 3 others will do in situ observations.
ये भी आपने देखा इस मिशन
To
के
understand
मिशन
changes in
डायरेक्टर
Earth's
SR विजू ने
ecosystem,
इस मिशन
study ice mass, vegetation, biomass, sea level rise. These observations and studies will help understand the groundwater of Earth and different natural hazards.
Automatic launch sequence initiated for PSLV C-57 Aditya-L1 mission.
The automatic launch sequence, the initiation has been announced, and hereafter a very critical capsule of performance validation for the launch vehicle systems will be carried out, and very close to the launch time, control will be passed on to the onboard computers.
जी हाँ, ऑटोमेटिक लॉन्च सीक्वेंस चालू हो चुका है। ALS शुरू होने के पश्चात रॉकेट स्वचालित होकर सर्वप्रथम T-0.3 सेकेंड्स पर RCT का प्रज्वलन शुरू करेगा और T0 पर कोर बूस्टर S139 का प्रज्वलन शुरू होगा। लेकिन इस दौरान वह स्वचालित तरीके से सभी जांच जारी रखे हुए है।
PS2 control system, redundant chain actuation in progress.
On your TV screens, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh. This mission is the 91st launch mission of ISRO and 59th of Workhorse PSLV. As mentioned earlier, PSLV's XL version with 6 strap-on motors alongside the core S139 motor is being used for the present mission. This is the 25th time PSLV XL is getting ready for launch. So far in the year 2023, ISRO has launched SSLV's maiden successful mission, 2 commercial missions of PSLV, 1 mission of GSLV carrying the first among the second generation of navigation satellites, 1 commercial mission of LVM-3 and another mission of LVM-3 again, carrying the prestigious Chandrayaan-3 spacecraft.
PS4 control system actuation in progress.
आदित्य-L1 जो कि एक अंतरिक्षयान है इस मिशन का, इसको पृथ्वी से 235 बाई 19,500 किलोमीटर की निम्न भूकक्षा में 19.2 डिग्री के झुकाव के साथ अंतक्षेपित किया जाएगा। इस कक्षा में निर्धारित आर्ग्यूमेंट ऑफ पेरिजी 346.6 डिग्री को प्राप्त करने के लिए PSLV के चतुर्थ चरण को 2 बार प्रज्वलित कर इसे प्राप्त किया जाएगा। आर्ग्यूमेंट ऑफ पेरिजी एसेंडिंग मोड और पेरिजी के बीच के कोण है जिसे कक्षीय तल के साथ मापा जाता है। आदित्य-L1 के इस दीर्घाकार कक्षा में अंतक्षेपण के पश्चात उचित समय पर और उचित अभिवृत्ति में अंतरिक्षयान में लगे लिक्विड एपोजी मोटर्स को फायर कर कक्षांतरण किया जाएगा और इस तरह 5वीं बार में LAM मोटर को फायर कर यान को पृथ्वी की प्रभावी क्षेत्र से बाहर निकलने में समुचित गति प्राप्त की जाएगी। फिर वह पृथ्वी की कक्षा से छोड़कर सूर्य की कक्षा में प्रवेश करेगा और ऐसा करते हुए यह करीब 125 दिनों का समय लगेगा। 125 दिनों बाद यह L1 पॉइंट के पास पहुंचकर और उसकी परिक्रमा करना शुरू कर देगा और यही वह L1 पॉइंट है जहां पर से यह अपने वैज्ञानिक उद्देश्यों का भी प्रतिपादन करेगा। अब हम उड़ान से 11 मिनट की दूरी पर
कंट्रोल सिस्टम एक्चुएशन इन प्रोग्रेस।
Let me in the meantime tell the viewers about the flight events that the launch of PSLV C-57 Aditya-L1 will take. This mission is among the longest flights of PSLV. It is going to last for 63 minutes and 19 seconds. The liftoff coincides with the ignition of core S139 solid rocket motor and the ignition of the 4 ground-lit strap-ons. While the rocket is at 2.7 kilometers altitude, the 2 airlit strap-ons also commence their operation. The action time of strap-on motors is 70 seconds and the ground lit and air lit strap-ons are separated from the ongoing launch vehicle at 70 and 92 seconds into the flight, respectively. The core S139 motor continues to thrust till 110 seconds. Since the second stage of PSLV operates on pressure-fed liquid engine, the optimal performance of the engine is ensured if the effect thrust cutoff or separation of the lower stage is countered by additional means of thrust generation. Therefore, the alleged motors provided for this purpose ignite 3 seconds before the first stage separation and continue to thrust for 11 seconds. The second stage, PS2, commences its operation 200 milliseconds after the separation of first stage. By this time, the rocket would have attained 55 kilometers altitude. The closed-loop guidance is initiated, which compares the present stage of rocket to the intended injection point to compute an optimal trajectory. This happens while the rocket is at 59.7 kilometers altitude. At 204 seconds into the flight, the payload fairing is separated as the launch vehicle attains 113 kilometers altitude and the dense atmosphere is no longer present around. These events are taking place in the operational regime of the second stage, which lasts for 153 seconds. PS2 is separated 262.4 seconds into the flight at an altitude of 130 kilometers, while the relative velocity is 4.9 kilometers per second. The third stage, PS3, ignites about a second later and burns for 118 seconds, during which time it adds 12 kilometers to the altitude and enhances relative velocity tremendously from 4.9 kilometers per second to 7.3 kilometers per second. There is a coast phase of 200 seconds that follow PS3 burnout, during which there is no thrust being developed, but the rocket continues to be steered. At 581 seconds into the flight, the PS3 separates and the last in the fourth stage of the rocket, together with the Aditya-L1 spacecraft, coasts for a long time thereafter. Till 1396 seconds into flight, the tracking stations at Shar, Port Blair, Brunei and back will be acquiring the real-time performance data of the flight. But thereafter there is no visibility period of around 1600 seconds or 27 minutes. The fourth stage burns twice. First time for a duration of 30 seconds and second time for a duration of 472 seconds. The first burn takes place in no visibility zone and the second burn is tracked by a shipborne terminal placed in Pacific Ocean. About 200 seconds after the completion of second burn of PS4, the injection conditions for the separation of Aditya-L1 are expected to be achieved. An altitude of 648.7 kilometers and a relative velocity of 8.9 kilometers per second, which translates into an orbit of 235 by 19,500 kilometers. The injection event of Aditya-L1 will be confirmed by tracking station at Kourou. From the initial placement in low Earth orbit, Aditya-L1 will undergo a series of earthbound orbit raising and eventually it will exit Earth's sphere of influence to reach Lagrange's point L1 in a journey spanning over 4 months. There it will be placed in a halo orbit around L1. This is how India's first observatory class space-based solar mission will take shape.
Vehicle is in internal battery power.
अब हम उड़ान से 6 मिनट की दूरी पर हैं। ALS जारी है। सभी जांच सुचारू रूप से जारी हैं। इस दौरान यहाँ उपस्थित आप देखिए यहाँ
External power supplies are withdrawn.
व्यूअर्स गैलरी पे, लॉन्च व्यू गैलरी पे उपस्थित जन आक्रोश, इनका रोमांच देखते ही बनता है। इतनी मौसम यहाँ लगभग 37 डिग्री का टेम्परेचर है, वायु गति 0.8 मीटर पर सेकेंड। इन सब के बावजूद यहाँ उपस्थित हुए हैं इस रोमांच को देखने के लिए। एयर ट्रैफिक कंट्रोलर और मौसम विभाग की अनुमति भी प्राप्त की जा चुकी है। विभिन्न ऊंचाई पर वायु गति माप ली गई है और इसे ऑनबोर्ड कंप्यूटर पर लोड कर दिया गया है।
The Satish Dhawan Space Center has its own meteorology department which keeps a very close watch on the weather at the launch base. Weather today is going to be dry and hot. The skies will remain clear. Ground winds will be benign and upper winds also are benign for the flight of PSLV C-57 Aditya-L1 mission. We are 4 minutes, 23 seconds to the launch.
सभी वैज्ञानिक अपने कंसोल पर आंकड़े देखते हुए सभी तंत्र सामान्य निष्पादन कर रहे हैं। अब हम 4 मिनट की दूरी पर हैं उड़ान से।
T-4 minutes and counting.
सामान्यतः PSLV के मिशन लगभग 2000 सेकेंड में प्राप्त कर लिए जाते हैं, लेकिन यह मिशन कुछ अलग है। इस मिशन में PSLV के चतुर्थ चरण यानी PS4 को 2 बार में प्रज्वलित कर यह उद्दिष्ट कक्षा प्राप्त की जाएगी। इसका मतलब PS4 को प्रथम कोस्टिंग फेज के बाद प्रज्वलित किया जाएगा, फिर 30 सेकेंड प्रज्वलित रहकर यह बंद हो जाएगा, फिर करीब 1600 सेकेंड की कोस्टिंग फेज जारी रहेगी। तत्पश्चात फिर से PS4 को प्रज्वलित कर 472 सेकेंड तक प्रणोद उत्पन्न किया जाएगा और फिर शांत हो जाएगा। आदित्य-L1 के कक्षा की स्थिति प्राप्त होते ही उसे निर्दिष्ट कक्षा में अंतक्षेपित किया जाएगा। इस तरह पूरे मिशन में लगभग 3800 सेकेंड का समय लगेगा।
T-3 minutes and counting.
यह PSLV C-57 का प्रमोशन यान ट्रैकिंग के संदर्भ में भी काफ़ी जटिल है। इसे ट्रैक करने के लिए शॉर, पोर्ट ब्लेयर, ब्रूने और बैग स्थित ग्राउंड स्टेशन हमें वास्तविक समय पे यान की जानकारी उपलब्ध कराते रहेंगे। लेकिन चतुर्थ चरण के प्रज्वलन के समय यान हमारे ग्राउंड स्टेशन की दृष्टि से दूर जा चुका होगा, इसलिए शिपबोर्न ट्रैकिंग या शिपबोर्न टर्मिनल को दक्षिणी पैसिफिक महासागर में स्थित किया गया है। वह हमें PS4 बर्न 1 और बर्न 2 की जानकारी उपलब्ध कराएगा। इसके बाद PS4 शट ऑफ और आदित्य-L1 के अंतक्षेपण की पुष्टि कुरु फ्रेंच गयाना स्थित ग्राउंड स्टेशन से की जाएगी।
T-2 minutes and counting.
अब हम उड़ान से 1 मिनट 50 सेकेंड की दूरी पर। यह PSLV की 59वीं उड़ान होगी और इस PSLV एक्सेल संस्करण में यह 25वीं उड़ान है। इसरो के वर्क हॉर्स कहे जाने वाले इस रॉकेट कई ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है, जिसमें चंद्रयान 1 और मार्स ऑर्बिटर मिशन उल्लेखनीय हैं। यह प्रमोशन वर्ष 2023 का 7वां मिशन होगा। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन, GSLV Mark II का 1 और PSLV के 2 सफल प्रमोशन हो चुके हैं। यह PSLV का वर्तमान वर्ष में 3रा मिशन है।
All stations stand by for the time mark. T-1 minute and counting. -55 seconds.
All subs are armed.
-50 seconds.
All sequencers armed.
तो हमारे साथ बने रहिए। अब 40 सेकंड पर
-40 seconds.
प्रमोशन किया जाएगा।
VSPP open.
-35 seconds. -30 seconds.
Real-time programs activated.
-25 seconds.
PS2 VSPP open.
-20 seconds.
PS1 ignition RMS arm.
-15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1 tracking. P3 tracking.
Magnificent lift off of PSLV C-57 with Aditya-L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने। इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill are just amazing. Ground-lit and air-lit strap-ons operating together with the first stage, S139.
Ground-lit strap-on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप-ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप-ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap-on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप-ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S139 motor still thrusting.
S139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated, second stage has begun its operation, and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya-L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated, third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर। और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, The third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलोन्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV C57 का।
For the present mission, after PS3 completes
Plus
its
6
burn
minutes.
duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the
Vehicle
PS4
performance normal.
will start twice at pre-designated times
Plus
and
7
duration.
minutes.
The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का, जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3, PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya-L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravati Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Jarhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth, the explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting, it is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक
Still
पृथक कर दिया
performance
गया है
normal.
और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लियोनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun while continuous communication link exists with the earth. These observations will generate a forewarning about disturbances in near Earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature, which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya-L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1 or L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrangian point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya-L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya-L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य-L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य-L1 के बारे में बात कर रहे हैं, तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph (VELC), which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में निधभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HE-L1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य-L1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VELC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही URO सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya-L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya-L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya-L1 mission, Dr. Durgesh Tripathi, PI of SUIT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 launch. To start with the principal scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya-L1 mission so important and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And Sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the Sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we move on to Dr. Anil Bharadwaj. So the Sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya-L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya-L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the Sun direction but also around it. Now when the Sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the Earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the Earth. What we are looking for from the Aditya-L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the Earth. We have instruments which look at not only in the Sun direction, but also in other directions, for example, perpendicular to ecliptic